morning, dear students. Today we are going to solve problems based on gradient of a scalar function. So, first problem is that these are the three problems which are based on gradient. So, first of all, if phi solution, if phi, which is a scalar function, which is given as 3x square y minus y cube z square, we have to find out gradient of phi at 1 minus 2 minus 1. So by definition of gradient of phi is equal to, we know that by definition, dabba phi by dabba x I cap, dabba phi by dabba y j cap, and dabba phi by dabba z k cap. Now this is equal to, so here we have to take partial derivative of phi with respect to x. So partial derivative of this with respect to x, which becomes 6x into y. Okay. So partial derivative of this term with respect to x is 0 into I cap plus partial derivative of this term with respect to y. Okay. So this is 3x square, and if you take partial derivative with respect to y of this term, so minus 3 y square z square into j cap plus partial derivative of this with respect to z. So derivative of this with respect to z is 0, and derivative of this is minus 2 times y cube z square into k cap. So this is the gradient of phi of this function. Now at 1 2 minus 1, which means gradient of phi, okay, at 1 minus 2 minus 1 is equal to, so here you have to put x as 1, y as minus 2, and z as minus 1. So 6 into xy, so 6 into xy, so that will become minus 12, okay, I cap plus 3x square, okay, which is 3 minus 3 times y square z square. So here it will become 4, okay, and here we have 3, which is 12. So here we have minus 8 j cap, and last term 2 times y cube z square. So 2 times, okay, y cube means here we have minus 8, okay, into z square, here we have 1. So again minus 16 k cap. So this is the solution of first problem, gradient of phi at 1 minus 2 minus 1. Now we are going to solve problem number 2. We finish problem number first. What is problem number 2? If u is x plus y plus z, v is x square y square z square, addition of this, and w is yz zx and xy, we have to prove that gradient of u, gradient of v, and gradient of w are coplanar vectors. So before showing these three vectors are coplanar, we have to find out gradient. Okay. So first of all, gradient of u is, by definition we know that gradient of u means partial derivative of u with respect to x I cap, partial derivative of u with respect to y j cap, and partial derivative of u with respect to z k cap. Now this is equal to, okay, partial derivative of u with respect to x. If you take partial derivative of u with respect to x, x plus y plus z, so that is only 1. With respect to y, which is 1, and with respect to z, which is 1. So we get gradient of u as I cap plus j cap plus k cap. So call this as equation 1. Similarly, gradient of v. Okay, so by definition of gradient of v, this that is nothing but partial derivative of v with respect to x I cap, partial derivative of v with respect to y j cap, partial derivative of v with respect to z k cap. So that is equal to, now we take directly partial derivatives. If you take partial derivative of v with respect to x, so here we have 2x I cap. If you take with respect to y partial derivative, so that will become 2y j cap, plus if you take partial derivative with respect to z, so that will become 2z k cap. So call this as equation 2. Similarly, we have to find out, okay, gradient of w. So again, by definition, partial derivative of w with respect to x I cap, with respect to y j cap, and w with respect to z k cap. Now this is equal to, you have to take partial derivative of this with respect to x. Okay, so if you take partial derivative with respect to x, this term partial derivative with respect to x becomes 0. Here if you take partial derivative with respect to x, so that will become z. Here y into I cap. Now we have to take partial derivative of w with respect to y. So z, okay, plus x j cap, plus next we have to take partial derivative with respect to z. So y, okay, plus x k cap. So call this as equation 3. Now we have to show that gradient of v, gradient of w, and gradient of u are coplanar vectors. Okay, so by property of scalar triple product, if their scalar triple product is 0, then we can say these three vectors are coplanar. So we have to take scalar triple product, which is gradient of u dotted with gradient of v crossed with gradient of w is equal to. Now see, from the definition of scalar triple product, recall how we solve scalar triple product. In the first row of this determinant, we take elements of gradient of u. So here 1 1 1, these are the coefficients. Second row, okay, here we have 2x 2y and 2z, and in the third row what we will have, z plus y, okay, then y plus x, z plus y, z plus x in the second j cap term, z plus x, and third y plus x. Okay, now if you solve this determinant, what you will get, this is equal to, so 1 multiply by 2y into this term, so that will become 2y square plus 2xy minus, okay, minus 2z into this, so that is 2z square minus 2z into x. Okay, so minus, if you solve second term, which is 2x multiplied by this, so that will become 2x square, okay, 2x square plus 2xy minus the second 2z into this, so 2z square plus 2zy, okay, and plus last term, which is 2x multiplied by this, which is 2x square plus 2zx minus 2y multiplied by this, so that will become 2y square, okay, and plus 2zy or yz. So see, 2y square, here we have minus 2y square for this term. Similarly, 2xy, okay, here we have minus 2xy. So in this way, all the terms will cancel each other, and finally we will get on the right hand side as 0. So do this as an exercise in your home. Each and every term will cancel each other, and their scalar triple product is 0. And by property of scalar triple product we can say these are the coplanar vectors. Now last problem, problem number 3. What is that problem? Find gradient of phi and magnitude of gradient of phi for phi 2x z raised to 4 minus x square y at point 2 minus 2 and 1. So by definition of gradient of phi, we know that, which is dabba phi by dabba x I cap, dabba phi by dabba y j cap, dabba phi by dabba z k cap. Now this is equal to, now we have to take partial derivative of this phi with respect to x. So that will become 2 into z raised to 4, okay, minus 2 into z raised to 4 we are taking with respect to x. So 2 times xy I cap, plus we have to take derivative with respect to y. Okay, so that will become minus x square into j cap. Okay, and plus partial derivative of phi with respect to z. So that will become 8x z cube into k cap. So here we obtain gradient of phi. So to find out gradient of phi at 2 minus 2 minus 1, so gradient of phi at 2 minus 2 minus 1, we have to put value of x as 2, y as minus 2 and z as minus 1. So this is equal to, see, 2 into z raised to 4 means 2, okay, because minus 1 raised to 4 is again minus 1. So minus 2 times x into y. So if you take 2 times x into y, so that will become minus 4. So minus 4 into minus 2, which is plus 8. So 2 plus 8. So here we have 10 I cap. Okay. Similarly, for j cap, minus x square. So x is 2. So here we have minus 4 times j cap. Okay. Plus 8 x into z cube. Okay, so 8x is what, 2 into z cube. Okay, z is minus 1, so cube of minus 1 is minus 1, so that will become minus 16 k cap. So this is the gradient of this function at, now magnitude of gradient of phi is square root of, okay, so we have to take square of this, all these three terms. So square root of 10 is 100, 4 is 16, okay, and 16, what is the square of 16? I forgot square of 16, okay, 36, 3, 6, okay, 9 plus 16, so 256. If you add all this, you will get square root of, so 256 plus 16, so this will become 300, and 2 1 362, 372, okay, 5 plus 6, and here we have that one. So magnitude of gradient of phi is square root of 372, okay. So with this we finish problems which are based on gradient. Okay, thank you.